Hello, this is the Bennett Castor Group. Week 5, I'm Reginald Bennett.
I'm Josh Costera.
This is July 8th, 2014, the summer term at University of Maine, Orono, with the Spatial Information Engineering Department. What?
Good. SIE.
So in week 5, we did some more stuff with Max Reaility, stuff with Visual Studio. I'll talk a bit more about Max Reaility a little bit later on, but we did start to prototype some stuff and utilize multiple static and movable markers. Right now, let's go ahead and focus on the Visual Studio and the coding aspect.
So we got the new SDK from Vuzix, which is version 3.6, and from what I can tell, it's exactly the same as the old one. All the projects still, the ones I were able to compile before, I can compile still, and I've started working on a different series of examples that are specific to the RAP 920 AR glasses. So it's the dual monitors inside the glasses and the marker detection. I'm very close to getting those to compile. I have all the libraries correctly importing and all the files needed. But the issue now is that they wrote theirs with an older version of Visual Studio. So it's actually a text encoding issue between Unicode and some other encoding issue that Microsoft has. So I have to see if I can work this out without having to rewrite all of the whole project. It may be an issue, but we'll see where it goes.
So as we said, we last week we got Max Reaility to function, and so we had an idea. Well, so we had 4 major ideas we want to do. We have one where we want to do a multiple, using one marker to indicate another marker, change a third marker. And so you'll see an example of this a little bit later on. The scale at which we wanted to do this was a little bit larger. It's convoluted the way that we have to. And so that's one of the reasons why we're trying to work out the actual software environment so that we can code this stuff outside of Max Reaility, because it's a bit restrictive on what you can do, and you can make things happen, but it's not really the efficient or intuitive way to do it.
The one thing with Max Reaility is you can't distinguish what objects get generated with what markers. It's how you assign them. So you have to think out your whole project and assign everything accurately or in the correct order. Otherwise, you could get confused because you don't know which objects technically correspond to which markers on that the camera sees. So hopefully with being able to do it in Visual Studio is we can specify which marker we want to correspond to which object gets generated. So we'll see if that actually happens.
Right, so as you input the objects, it starts to actually assign each object in a sequential order. So if you don't plan the whole project out as mentioned, and all of a sudden you have 12 objects assigned and then you remove number 3, it will actually reassign everything above that in the stack down, which it's just, if you're trying to make markers using the real world and you want to label them, be like, hey, this is a couch, or hey, this is a whatever, or this is a dragon, all of a sudden now they've been reordered and your markers no longer apply. It's just not having direct manual control over that is irritating. So we want to orient you a little bit, because we said early on in this project that as we learn stuff we want to kind of share how that works. So we'll show a quick video that we took earlier of the way that Max Reaility is set up. First I'll show you this kind of screenshot, and in here on the left screen you'll see there's 4 quadrants in 3D Studio Max, and in the middle is the actual our augmented reality viewer from Max Reaility. And so you can see in that middle window that one of our markers is actually covered with a green square. It's that green square you see on the top left quadrant of 3DS. Then on the right you just see different orientations. Where the camera is really doesn't matter except for the angle. There's some part in here that actually determines its distance on its own based on the size of the marker and whatnot. So yeah, you can try and move the camera as much as you want, but in the end when it renders it doesn't matter.
Yeah, it's all about the actual size of the object, so what determines how big it gets displayed, or kind of determines how big it gets displayed in the view. And we're not sure. I'm guessing if they have some sort of static value they set, that the camera's always set to this value, and then just it draws its object as big as it wants.
So when you make your first project, what we found is we made a thing called a template. You can see that at the top of the screenshot. And essentially made a little box that fits exactly over the marker as you see in the window itself. So what you want to do is, make your first template. That way, everything you make after that, you have a relative size orientation on how big it's going to be. Now you'll notice in the top left quadrant that you only see 4 squares, and actually only seeing part of those 4 squares. That's something that's interesting about the way that this is set up, is that you can't change the scale, at least as far as I've seen, at which size things are rendered. So is that a big deal to some folks? Or initially it may not seem like it is, because if you're just creating everything right inside 3ds Max with sliders, it's okay. But if you want to actually set things to, let's say you want to set something to 25 units because you want to try and actually have it replicate to some scale that is realistic in the real world, other than just sliding something back and forth and trying to just eye it. You're not going to be able to do that, because the way that 2012 does size is it approximates down to only so many digits. And since everything that we're creating is under 1 unit, it's not as precise as we'd like for an augmented reality solution. Like I mentioned earlier, a couch. We didn't take that video. We'll do that next week. We had a couch demo we did where you can take a marker, place it around the room, and you can see where that couch will be, what will look like in that room, or a desk, things of that nature. So it helps you to kind of predetermine how you're going to build a room before actually having to move all these heavy objects. But if a couch is actually 6 feet and you want to make it 6 feet, then you have to just slide it around until you get a guesstimation that it's in the right place.
Basically you have to watch the video until it looks to be an accurate size, and then that's the value you need to use. So make your objects really small and scale them down, and then you can get it a kind of approximation. On the right there is the toolbar, and we'll kind of talk you through that here. So right now, this is going to be a project we'll show you in a little bit. We have a bunch of objects in here. We have a sphere, kind of a tilted cylinder. We have a torus in there, a box, and then the long object is going to be our pointer. With that pointer, you have to set it as a trigger object later on. You have to set all these different things. And on the right, you'll see the Vuzix window, and that's where you can launch or export to VWD. You set the camera, and those settings didn't do much. The portals, we'll explain in a little bit more detail after this video, but the portals are how you set up for when a trigger object touches something that you specified, it will go to the specified VWD file. So there you can see it was a sphere. Next, we didn't do any of the sounds or animations in this one. Next one is interactive objects. We made the pointer an interactive object, so that means that the pointer, that long part, it's actually a cone, will interact with other things it touches. So this is the layout of the markers that we had on the desk in order to show this demo that we'll show afterwards. But you can see the 3 markers on the left all correspond to an object. The top one is a cylinder, the middle will become a ball, and the bottom one will be a torus. And then the static marker 0, that's 0, which is in the top right, defines where the whole scene will be drawn. And then the movable marker on the bottom right will actually be that long pointer that we had just talked about. And when that pointer passes through one of the other objects, that object will get drawn above the S0 marker on the top right.
Now something, a couple details there. One, you can actually test a lot of the AR functionality without using your glasses, because glasses, when you're trying to just test stuff quickly, it becomes kind of irritating putting the glasses on and off. So if you actually disconnect the glasses, the system will recognize you have a webcam, and it will actually let you do this stuff with just a webcam. So we were doing a lot of testing that way, and then once we have something we like, then we plug in the camera and make sure it's working the way it's supposed to. Another thing on here, and if you do that, it will say, hey, no Vuzix, it couldn't be detected, and then you just hit, go ahead and play without it, or disconnect it, I can't remember what the term is. When you want to put the glasses back in, you have to start a render or a Max Reaility situation, and then you have to hit F2, or I think it might be F3, to restart all the hardware. If you hit F1, it will tell you what it is, the hardware reset. And once you do that, you can go back in, and it will be back on your glasses. And then if you take the glasses back out, then you can again disable it and just look at the webcam. So that was good. Another thing is on here is if you obfuscate any of the markers, then your static marker, in that S1, you can see this little paddle that's near the keyboard on the right. That will be the base orientation and will become the master to a slave relationship of all the other markers. So in a second, I'll get to that in 1 minute. So when the scene starts, you notice in the first window that everything is piled on top of each other. That's because in order to have the objects orient on top of their marker, they have to be at 0, 0. And so even though these aren't all our markers in real life aren't stacked, in the actual VWD or the software situation, you have to make them all stacked and then assign them to the markers. And then once the software sees the markers in different location, it will put the object on top of that marker. If you offset it from the beginning, trying to make it look spaced like this, then all that will happen is you'll have a greater offset once it recognizes where the markers are. So yeah, when it's not running, you're going to have this big stack of objects. And just understand that and just kind of get over that. Okay, so the next thing is the static or the S0 marker will be, like I said, the master to slave of all the objects. So if it never picks up a marker that it's assigned to, like let's say M3 is the one that we're seeing here in the bottom left, if it never sees that, then it will leave it stacked on top of F0 or S0, the static marker. So you got to make sure there's a scene. The next thing is, if the static marker is covered, make sure I said that right. If the static marker is covered, the movable markers will still be attached to the movable marker just fine, just the way you'd expect it to. If a movable marker is covered and the static marker isn't, if you move that static marker, whatever the last relation, like spatial relation was between that movable marker and the static marker, will maintain. So if I cover up S1 with my arm or something like that, and then I move, if I cover up M1 with my hand or something, and then I move that initial static marker to 0, 1, then the object will move with that static marker in a way that you don't want. So one of the things we're considering is just making everything a movable marker, because in that case it understands not to slave the object to some just arbitrary marker just because something got switched up. That's another, we'll talk about a little later on, this thing called PTAM, parallel tracking and mapping. That's another reason why the coding environment is going to be a little bit better, is because we'll be able to manually fix some of this stuff that has some issues. Yeah. And then over to the right, you can see the menu. And what I want to point out is where it says situation 3 root, situation 3 cylinder, situation 3 circle, and torus. I'll explain a little bit after this video, but those are all 3 different complete scenarios that have assignments to each marker in different situations. Those are all different branching options that you have to do manually with different files. So here's the video on how the demo looks right now. So remember what those look like. Right now the big pointer is selected. You'll notice that when we touch an object, it collides. That when it works right, then it will change to that object, and that's based on some settings we did. Now we notice, like right here, when you're seeing it try to touch the purple cylinder, that it has like some issues, and that's something.
Yeah, they have in 3ds Max you can actually define a range, and we're not sure how, if the range is like a box around the object, or if it's just within a certain distance in one direction, like the X, Y, or Z. So we have to play around with that to get it more accurate. Hopefully it can just be, as soon as the 2 objects collide, they change.
And you'll see here too that you'll notice that each time that the object in the bottom left was changing, that was actually a different file here. So whenever you saw the circle, it was because the program had called up situation 3 circle, or if you saw the torus there, then it was because it called up torus. Now something that was mentioned just now was that range thing. By default, Max Reaility has the range at 100, which means that when it's initializing, before it even sees the markers all separate, it's going to have a collision initially. And unless you have the markers way separate, it's going to keep colliding. So our first test, we just kept seeing everything just like swapping back and forth. And that's because the marker was within 100 of everything, and so it was just switching between all 4 files very quickly. So to mitigate that, one, we moved the pointer off. So you'll notice even when we initialize, the pointer isn't exactly on top of all those other objects. You notice that if you go back, Here, let me go back real quick. Nope. Right there, you can see on the left the pointer's not touching, and that's so that in those first few split seconds it doesn't trigger. And so, yeah, and then you also have to lower the range if you don't want these things to consistently trigger. Now, one thing we noticed with the desk, and you don't see it so much with these because these objects are so big, is that when we put the desk in the room, what we're seeing a lot of...
There was a lot of jitter, almost like it was the camera was having trouble detecting like small angle changes in the marker, so the desk literally looked like it was just shaking back and forth.
Right. So, and that's not normally what your furniture does. So, if you're trying to get a feel for what everything looks like, you know, having your desk do a little dance with, you know, like a 3-foot wobble isn't necessarily accurate. And I think where that comes from is the where the software is doing an estimation on where the picture or the marker orientation is. It's getting a slightly different angle with every frame, and so hopefully manually we can code an average in there, or hey, if the marker hasn't changed more than X%, then don't re-render it at a different angle. Leave it there. It's probably just detection, you know, error.
Yeah, and part of it also, I think, the bigger the object, the more that air is going to get magnified in the motion of the object. So if you have like a small sphere at a far distance, you don't notice it moving because it's such a small object. But with something as big as a desk, you notice that movement a lot more.
Right. So, yeah, again, that's something that we hope to be able to mitigate inside of our own manual code. So just to explain how that all worked real quick in case you try and do that demo yourself. Essentially, we set up situation 3 root, we set up the pointer, the 3 objects, and then there's a base box initially. And then all we do is we say, hey, we set the pointer to be a trigger, and then we, inside of the interactions, we go ahead and we set it so that if in the portal settings, because what a portal does is when something interacts with it, it portals in a new VWD file, which it just reloads a different simulation. And so what you have to do is a lot of redundancy. Each one of those files, situation, circle, cylinder, and root and torus, all have all the same boxes and everything. They're all completely different files. The only difference being in there is that for situation 3 cylinder, the cylinder is the thing that's displayed in front of you, is the thing that's selected. So again, not very efficient, not the way that I've ever wanted to code something.
Yeah.
So, but that's what we did. So you go in there, you set the portal and say, hey, when you set the trigger to the pointer, and then you set, you click on like sphere, you add it as a key item, and then you select the VWD that you want to load on trigger, and we set that to situation 3 sphere, or circle in this case, because I didn't keep the naming convention straight. And then you have to set each one of those conditions. So when you're in torus, you say, hey, if the sphere is touched, go to sphere VWD. If the torus is touched, or the cylinder is touched, go there. And then don't have a redundant inside torus. Don't let it like go to torus, because then you can have a lot of resetting over and over, and you probably can introduce more error. Yep. So we had to go situation or VWD by VWD, doing that over and over, setting those conditions. Again, it's brute force and get it to work, but and to average users, they may not notice that anything special happened there, but not the most precise way. And that was the only way we could get around making, because the Max Reaility doesn't come with the ability to make
assign custom markers.
Right. Yeah, then that's the only way we can get around that. So yeah, so that's kind of that project this week.
So
yeah,
we talked about how Max Reaility is restrictive in the sense that you can't assign the custom markers, and like we discussed, how having to do that very simple, just selecting 3 different objects required like 9 different files and a whole bunch of stuff, which is more complicated than it necessarily should be. But for now, that's what we got to do until we can get the coding environment working, and then we can hopefully do it much easier and more simpler, I guess. And
to make it like an absolute clear point, though, when we keep saying custom markers, can you grab a marker real quick? This, in real life, you don't want to see just markers like this out there when you try to do stuff. We're hoping that, with a selection thing, let's say we're going to select different cars. We want the software to be able to look at a selection of 3 different cars, and then when you point at that car or whatever, then you get a reaction, or you get something rendered over that car or something like that. We don't want to have to put these like huge blocky things in the middle of real life, because those are just distractions. And we have seen some AR demos with that functionality, but we haven't found anything that was super easy to do that. if you want to talk OpenCV.
Yeah, so OpenCV is a library that is used with some of the demos for the SDK and also in a lot of other AR projects. And it's a image. It detects images and then can do like line detection, color detection, blob detection. It can do a lot of image processing. So it will hopefully become useful for us when we do some marker recognition with the code. We'll probably be using OpenCV to detect those markers and then do something with it.
Once we found out that Max Reaility was as restrictive, we can do simple things, but nothing like overly complex. We can't do any brain power behind the displays. We can display things on 1 or 2 levels deep, but past that we can't really do any type of scripting. Again, we tried to do the AR media thing, still couldn't get it to work. Even looking at their documentation, it doesn't work exactly how they say. So then we looked into some other options and some other augmented reality options, and we saw some things like an AR toolkit, which I found was very interesting. That was in a lot of places too, not as many as OpenCV, but a lot of examples of people using that. But when we went to download the SDK for it, things from like 2007, and so it worries me when things don't have very much community support for more than 5 years, more than 2 years actually.
Yeah, I mean it's 7 years old at this point. And this is also an issue we run into with the SDK, because the SDK is old, and you're going to require older software, which may not run with the newer libraries, and that's kind of one of the issues we're running into currently with the coding in Visual Studio. Is I need SDKs from 2009 or even 2005 Microsoft SDK, and you can't get it anymore because they're like, oh, here's a newer one, this is better, and really I don't want the newer one. So
we looked into these other ones, the AR UCO, Goblin XNA, which is based on. It's an augmented reality thing based on Microsoft's XNA program. And then this PTAM thing, which is kind of the last thing we'll talk about today, which shows a lot of promise as well. So PTAM is parallel tracking and mapping. And so what was really cool about that is, we mentioned it in one of our videos earlier, that if you show a marker and then the webcam no longer sees that marker, it essentially either it leaves whatever it's rendering in a static location, no longer moves. Even if the marker is only partially covered, you cover it with your thumb or off the screen a little bit, then the marker just disappears. Especially in the case of if it's on a desk or something, it will either disappear or just become static. That's an issue. With this PTAM or PTAM, what they're doing is not only can you do marker recognition, but the system intelligently looks at the surroundings and then actually starts making its own markers based on what it sees. So if you're looking down at a desk like we were earlier, and the PTAM sees a keyboard, not only one will it recognize the markers, but then it will also start making recognized coordinate points on like corners of keys, on the corner of a monitor. Any distinct visual artifact it finds, it marks down and keeps as a coordinate, so that if the perspective changes, it can use those other points and those other coordinate values as a point of reference for what it should be displaying. And so what that means is, in the example of a couch, right? And again, one of the demos we're looking at is trying to make a room and kind of preview what it looks like. If you look at a marker, right? A couch is 6 feet long, let's say, and you have one marker in the middle, and you want to look at the left side of the couch, and all of a sudden you are no longer looking at the marker for some reason, but you should. In reality, you should still be seeing part of that couch. With the regular system, the couch would just disappear. With this system, or even if the couch didn't disappear, let's say you don't have it or it fades, then what would happen is it would just stay in your view and it would move statically with your eyes instead of staying where it was supposed to be relative to the room. Whereas with the PTAM thing, it would see corners, walls, posters, whatever, and mark those as coordinate points, and then when you looked away from the marker, it would be like, okay, I know the marker, I can't see the marker, but I do know that the render was here relative to this poster. So you would now be able to see a corner of this object. So that's pretty cool stuff too. Yeah, there's a bunch of stuff that we want to.
Yeah, there's a whole bunch of demos too for PTAM that we were looking at. I didn't find any coding or actual code for it or look into it that much as far as the code, but I'll probably look into it next week, because if we can use that as well as a coding base, it'll be a pretty good start, because then it'll open up the world of markers basically.
Yeah, so that's what we got. We got some functional low-level demos that we can do. Obviously, we can spruce those up with better graphics and then try and figure out the jitter. I'm not sure if we can affect that or not with Max Reality's current software, but hopefully. And yeah, we'll have another video next week.